Hello, Cardinals. It's Mr. Mon, and we're going to talk about Lesson 7 reflection today. The focus question is, how can weather data and patterns be used to predict future weather events? Before we begin Reflection 7, we're going to look at Question 6 from Investigation 7.3, and that's where, as a group, you should have decided about the most interesting observation, and you're going to be sharing that with the class. You're going to explain why it was interesting and what it taught you about weather and predicting weather. So a little step back a day to discuss interesting observations that were made. And then if you get time, we're going to go back to objective number 2, and you're going to write what patterns you saw in your weather data. For Lesson 7 reflection, we're focusing on constructing a scientific explanation about current weather conditions to make predictions. And I want to go through the vocabulary for you. The first one is weather fronts. A weather front is a boundary between two air masses of different temperatures, pressures, and humidity conditions, and that's where they collide. And as you can see on this picture of weather, this would be a cold front. This means that cold air is moving this way, and this would be warmer weather, warmer dry. This is probably cold and moist, heading that way. This would be a warm front, and that's so the different symbols point which direction the front is moving. Cold front is the leading edge of a moving mass of cold air, and what happens in a cold front is when a cold air mass pushes a warm air mass ahead of it, the dense cold air slides under the light warm air. The warm air rises. If it has water vapor in it, the dense cumulonimbus clouds form and rain or snow may fall. Cold fronts move quickly. So as you can see in the diagram here, you have warm air, and the cold air is overtaking the warm air, which forces the warm air up. As that warm air goes up, it condensates, and that's where you get your big thunderstorms. A warm front is a moving warm air mass that overrides a cold air mass ahead of it. If the warm air mass is dry, scattered clouds form. If the warm air mass is humid, rain normally falls along the front, and warm fronts move slowly. So here you have the warm air overtaking the cold air. Because the warm air is less dense, it rises, and then these are those days you can either get a cloudy day or you can get those all-day rains, those days where it just kind of rains all day. How has weather forecasting changed? Before the mid-1800s, they relied on clouds and winds, the old farmer's almanac, past experience, animal behavior, arthritic bones to predict the weather. And then Joseph Henry, the first director of the Smithsonian's, developed a network of volunteers to share weather data across the United States. He posted weather data on a map at the Smithsonian, and once they had the data, they analyzed it and saw patterns. They used a telegraph to share their predictions of upcoming storms. Dual polarization technology is a tool that sends out both horizontal and vertical waves that allows us to tell what is in the air, so rain, snow, or ice, and it can also detect debris from tornadoes in the air. Multifunction phase array radar is used by the Navy to track enemy ships, and it's being used in weather to give meteorologists more control in looking at radar, so you can get more accurate weather forecasts. And then unmanned air vehicles, and these are vehicles used in storms to collect data in areas where it would be unsafe for people to go. So they're using drones to fly into and through storms to collect data. Looking at your reflection, the first part is this, is you're going to discuss the information from your student sheet 7.2, and then how did your answers compare with those around you? And if you could revise some answers, what would you change it to and why? For part 2, you're going to be following you're going to answer the following questions with your group and record your answers. So you're going to look back over the graphs you made from your data, and you're going to think about the relationships between the data you collected and the weather that followed it. And then how can recording data about the current weather conditions help you predict upcoming weather? You're going to use evidence and data from your investigation to support your conclusions. So you're actually going to cite evidence from your data. And then what reasons or explanations could you provide on how evidence supports your conclusion? Part 3 is reading your extended knowledge, the father of weather forecasting, and you have some questions to answer there. And then you need to read weather forecasting in the 21st century, and you have some questions to answer there. So Your to-do list for today is to do lesson 7 reflection, steps 1 through 5. Some of this will be in a group and some of this will be on your own. Make sure you're reading both articles. You do have a KWL on Google Classroom that you should update. And then all of your vocabulary should be done, including the 3 new ones today: how weather forecasting has changed, National Weather Service, and technology we use for weather detection. There is an exit slip, and remember to prepare for your quiz on Monday. If you have any questions, please let your teacher know.